right, welcome back, class. Last week we talked about the five components of health, health-related components. So those five are things like cardiorespiratory endurance, muscular strength, muscular endurance, flexibility, and last but not least is body composition. So we broke down those five. I think we have a good understanding of what each one essentially is, right? If we want to do a muscular strength activity, we're going to be doing a 1 repetition maximum, or running as hard as we can for a burst. If we're going to be doing muscular endurance, we're doing exercise over time like push-ups or sit-ups. If we're doing cardiorespiratory endurance training, we're walking, jogging, cycling, something of that derivative to encourage that kind of metabolism. And then last two, flexibility, right? You don't use it, you lose it. So stay flexible, that's gonna be key. Maintain that from the time you are young throughout your entire years of life. Making sure joints can move through their full range of motion is gonna be very beneficial. And to put the whole puzzle piece together, body composition. That's finally gonna sum up all those derivatives, right? Those key four components, and that fifth component, body composition, that's telling you your overall fatness, you could say, or muscle, fat-free mass to fat mass, and we always want to keep that in control as the end-all be-all. Now we're going to break into exercise instead a little bit more specifically and learn about key energy systems that the body does have. There's three key energy systems that we're going to be focusing on how the body utilizes energy, and it's really based off of, one, the intensity of the exercise, and two, the amount of, I guess you say, overall heart rate necessary to control that or to maintain that type of exercise. So we'll see the three different branches come out pretty clear. Let's go ahead and term our systems first, just so we have a better understanding of the physiological aspects and the anatomy as well. So if we look at any heart, or we look at any, diagram of a heart and the lungs combined, okay? When we see those two in combination, we're talking about the cardiorespiratory system. And to define that, the cardiorespiratory system is a system that circulates blood through the body, and it consists of the heart, the blood vessels, and of course the respiratory system. So from your nose and mouth all the way down your trachea to your lungs, right? And then we're looking at then the heart as that four-chambered vessel, sending oxygenated blood to the body, and then bringing back deoxygenated blood. And we'll define those terms as well. The first thing is the heart, right? As I said, it's four chambers, and it's about the size of your fist. So if you take your fist and you put your hand over your heart like you're saying the Pledge of Allegiance, roughly on the side right there, that's about how big your heart is. Four-chambered vessel, or four-chambered structure. Now there's two circuits. There's the pulmonary circuit. And the pulmonary circuit's purpose is to circulate blood that moves between the heart and the lungs only, okay? And this is controlled primarily by the right side of the heart. Versus the systemic circuit, that is important in circulating blood to the entire body, like to the tips of your toes and fingers, to the top of your head, all right? So we're gonna be seeing different types of blood then in these vessels. Now the heart has oxygenated blood and it has deoxygenated blood, but the great thing is that it has a very muscular wall down the center of it, which prevents the mixing of these bloods. I don't know if you ever heard of like a baby that might have a heart condition at birth. Sometimes there's a small hole that when the baby's inside the mother, that's going to be bringing blood in from the umbilical cord right to the baby, because the oxygen is coming from the mother at that time. The lungs are not functional, so they need that support. And during birth, that hole actually seizes up. But sometimes that doesn't always happen, so we have a little bit of a leak, or it's called blue baby syndrome, where they're not getting a full oxygenated blood supply produced by our lungs because there is that small little hole. Fuse that hole, and there should never be a problem with most kids. Now, getting into more on this information though, strictly with the heart, what we need to know, okay, is with those four chambers, we have the left side and the right side of the heart. The right side of the heart, right, is going to be receiving blood, right, and then pumping that blood then in turn to the lungs to get oxygen. So blood has already been to the body. It's returned to the right atrium of the heart via the superior and inferior vena cava, which are the largest veins in the human body. The right chamber fills up with blood, the right atrium, that pumps blood down to the left atrium, left ventricle, my bad. Sorry, I said it all wrong. Let me go back and redo this for you. The right atrium brings blood. The right atrium receives blood from the top of the head and the torso, right? So blood's coming in here. From there, it's going to send blood downward. The blood is then going to go into what is known as the right ventricle. I'm just going to put an RV right there, right ventricle. From there, the blood is sent out to the lungs, right, via the pulmonary trunk, and there oxygen is put into the blood. From there, blood vessels bring blood back to the left ventricle. Left ventricle. And that's oxygen rich, right? Sorry. Let's break down the circuits of the heart real quick, just real simple. If you want to look at a diagram on your computer, now's a good time to pull up a picture from Google. We're looking at the internal structures. But if we look at the heart, to keep it simple, it's a four-chambered object. Okay, it's going to be receiving blood from the superior and inferior vena cava into the what's known as right atrium. From there, it's going to send blood downward to the right ventricle, and that's going to forcefully pump blood up to the lungs. Little L's, little lungs. From there, the blood that is deoxygenated already, right, it's going to be receiving oxygen from the lungs. And then in turn, the pulmonary circuit is going to bring that blood back into what's known as the left atrium. The left atrium then is going to send blood downwards to the left ventricle. And this is a very muscular wall here. All right. Why? Because it has to forcefully pump blood with every beat up to the top of your head, down to the tips of your toes. Okay? So this is pivotal. What we're going to see is that the left ventricle is going to be strengthened the most by doing muscular strength and especially muscular endurance activity by far. So we're looking at, right, doing push-ups over time, doing sit-ups over time, stuff that requires strength, but the endurance of strength at the same time. So yeah, you want to focus on your heart. Don't only run, right? Throw some variety in there. Do some little bit of muscular strength endurance training. Now, so we've covered the heart. So we know that we have oxygen rich, O2 rich on the left side, O2 poor on the right side. Now there are a couple other structures to know about, but I'll let you research that on your own. The main thing that I want you to know about is that there are two specific types of structures that take blood away from the heart and bring blood back. Okay, so those are mainly called veins and arteries. Arteries are the ones that are going to be thicker and stronger because they're taking blood that's forcefully pumped away from the heart and sending it to the body. Versus the opposite way, veins, you can see those just underneath the surface of your skin, often looking blue in nature, deoxygenated blood, right? Those are bringing blood then back to the heart. The heart's receiving that blood to, remember, take it back to the lungs and oxygenate it then. The key things that we're looking for sometimes, though, if we want to learn or check blood pressure, are the systole and diastole segments of pressure within the blood vessels, okay? So the heart, right, the heart's going to be a four-chambered vessel. It's going to be pumping very hard. So when it pumps blood through the body, it's like a hose, right? The pump pumps the water, and then from there, the water has to come up the hose. And if the pressure is too great, right, the hose can burst. If the pressure is higher, right, it's going to push the blood faster even too, as long as the wall is stable. So an artery is going to have a thicker wall because it's taking blood to the body. It has to be able to take on that force, that strength that forces through it with the water, or in this case, right, not a hose, with blood, with our blood vessels. And vice versa then with the other portion of it, diastole, so we'll get to that here in a second, that's really what we're seeing as pressure when the heart is at rest or relaxed, okay? So systole, okay? We always look at blood pressure. Blood pressure is key, 120/80 is the goal, millimeters of mercury, mmHg. So if we have 120/80, 120 is your systole, the pressure in the heart when it's contracting or in the blood vessels when it's contracting. And then 80 is the pressure in the blood vessels when the heart is fully relaxed, all right? Our goal is to be 120/80 with anybody and everybody. Now, seeing a little bit lower numbers, there's really nothing wrong with that as long as it's always consistent. But seeing numbers higher is very detrimental to the body. So we have prehypertension. That is characterized as 130/90 millimeters of mercury, all right? High blood pressure is when we have 140 or 140/90 or higher, usually speaking. So our key thing is our goal, normal blood pressure, 120/80. Know that for the first exam here coming up. Know the basic chambers of the heart for the first exam, right? And then we can determine blood pressure. Okay, anyway, we'll figure out how to do that later on with blood pressure. I'll show you how a cuff is used, but it's really hard to do right online. Not exactly the same thing as in person. So we'll skip that for now. Jumping into some more information, okay, the heart is going to have that strength that we were talking about, that volume of blood that's going to be pumped from the heart. So it's very powerful, right? The heart's very powerful. And with the heart being powerful, we have a combination of stroke volume times by a heart rate. Okay, stroke volume times heart rate is going to equal what's known as CO, cardiac output. So these are interrelated objects, right? When we raise one, the other one's usually going to go down. They're inversely related, we could say. So if we just think about this, okay, if your heart is weak, it's only pumping 60, and you have a heart rate of 60, that's equal to 360. But if your heart is strong, right, it can pump more blood with each beat. Say it pumps 100 volumes of blood, the heart rate can go down lower now. The heart rate can go down to 36. That's like Lance Armstrong style. So Lance Armstrong, in a sense, right, even though his heart rate is lower, his stroke volume is greatly increased. So this is going to allow him to pump blood more efficiently. His heart doesn't have to work as many times in his entire day as an entire lifetime, per se. Efficiency is key here. So that's another reason why I want to do muscular strength, muscular endurance, and cardiorespiratory endurance training. Our goal is to get the heart to be more relaxed at rest, right? So it can have a lot more longevity and be stronger, and then keep your blood vessels cleaner, right? Preventing the cardiorespiratory diseases in the long run. Okay, those energy systems. We'll talk about those three real fast and we'll call it a day. The three energy systems, okay, are first off the oxidative system. Secondarily, we have the glycolytic system, and then we have the creatine phosphagen system. All right, now with these three energy systems, we're looking at different types of fuel the body is using. The oxidative system, first off, is going to be like our cardiorespiratory, we got to think of aspect. It's going to be when our body is utilizing oxygen as its primary fuel to burn carbohydrates and really primarily to burn fat even more. We like to say that carbohydrates are the fuel that burn fat. As soon as the body is done burning up its carbohydrates, all that's left over for the body to burn now is fat that's stored within the body. And by burning off fat, right, it's a very energy dense type of material. Our body can hold that, and by getting rid of it, we can improve our body composition over time. So oxidative stresses are when we usually keep a heart rate with kids, and especially with adults, somewhere below 140 beats per minute. Oxidative. And lower. So this would include something like a light jog, or maybe a faster jog if you're more well trained over time, right? Your body's gonna be becoming adapted over time. But we're looking at when we're just sitting here right now, we're using our oxidative system. We're mainly burning fat as our fuel. We haven't tapped into these other types of muscle fibers which use sugar, or what we like to call glycogen, as its primary fuel source. The body basically, to keep it simple, whenever we ingest carbohydrates, it's increasing our glucose in our blood. And glucose is a simple sugar that circulates in the blood and is used by cells to use as ATP, which is our basic fuel production in our body. Glycogen, on the other hand, are complex carbohydrates that become stored in the liver and the skeletal muscles and are used as major fuel when we're trying to do very more, as you could say, intense muscular endurance and strength training activity. So in order for us to burn the fat, we need to use the carbs, use the fuel, the glycogen first, get rid of that glycogen. That way our body only has to resort to utilizing our fat storages, that we can constantly improve body composition. We talked about ATP. Simply enough, ATP is adenosine triphosphate. It is the energy source for cellular respiration or cellular processes. Those energy systems, right? We covered oxidative. We use that all the time, no matter what, whether we're doing muscular strength, endurance activity, you name it. So this is our end-all, be-all. We already talked about that 30 minutes per day, 5 times a week equals our 150 minutes at a moderate intensity. And our moderate intensity be right there at our 120 to 140 beats per minute. If you go higher, right, you can't sustain that for as long of a period of time. Now we're going to start tapping into another energy source. And this is going to be that intermediate, or what I like to call this as the glycolytic energy system. This is when our body is using glycogen as its primary fuel source. It is overall intermediate, right? our cells or our muscular endurance is where it's going to come into play here. So we're going to be able to do exercise that is definitely harder than non-oxidative stress. So say for instance we jog, we run at a slower pace. Here a glycolytic would be our muscular endurance, so push-ups, sit-ups, doing as many as we possibly can over a given period of time, or trying to just do as many as you can until absolute failure. That is muscular endurance. So with our glycolytic system, in order to stress that, we're usually getting our heart rates up a little bit higher, and that's in turn going to cause us not to be able to keep up with that level of activity over time as far. We also have to deplete our glycogen, right? And once we deplete our glycogen from that system, another time that is when we're going to absolutely fail with muscular endurance. This type of training is wonderful to the body because if you're doing this style of training, you're doing a lot of repetitions overall, you're doing overall lower volume, so you're not using as high of an intensity, right? So you can maintain that over time. And a way you can tweak that is to even slow down exercise more. And say you're doing 40 repetitions or something, right? And you're just not feeling like you're getting any more benefit. Try doing 20 at half the speed, going up and down from your push-ups or sit-ups. That way you're still using that glycolytic system and stressing the body in an entirely different nature. The last portion of the body is going to be the non-oxidative, or we say anaerobic. Anaerobic means without oxygen versus aerobic exercise with oxygen. We can keep up that breathing rate. This is where we hold our breath and we can do a 1 repetition maximum, for instance. So I want to pick up one thing as heavy as it is, I pick it up and set it back down, or I bench press one thing as heavy as it is and set it back down. This is where we're really focusing on that anaerobic training. But anaerobic training usually is up to 80% of your 1 rep max, all the way up to 100% of your 1 rep max, 1 repetition maximum, right? That's the percentage of the most weight you can do. And you're looking at doing repetitions between 10 to only as little as 1 at a time. Again, we don't need oxygen, so we don't even have to technically breathe during this process. The system's only going to last maybe 30 seconds to 45 seconds at the most, versus the glycolytic system, which has the capabilities to last 2.5 minutes easily. We're looking at exercises like an 800-meter dash, right? You're doing 2 full laps, and that's going to burn out that glycolytic system completely. A mile? Yeah, we're looking more along that oxidative stress. Sprinting 100 meters like Usain Bolt? Now we're looking at that final one. We call this creatine phosphagen. Creatine phosphagen system, our muscular strength system. To be complete in fitness, we need to stress all 3 if possible. I like to start here because we guarantee we burn off as much energy that's in the muscle stored, as much energy and sugar that's in the body is stored. That way our body can utilize fat as its primary fuel storage, and we can improve our body composition overall. The more muscle we build in these 2 systems, for every 1 pound we can burn off another 40 calories per day. So how wonderful. If everybody could gain 10 pounds of muscle, lose 10 pounds of fat, you greatly improve your body composition, right? And then you're burning another 400 calories a day, so yay, you can have another serving at every meal. How nice, right? Stay tuned for more. We're going to jump into more information specifically for kids. But again, like I said, this is generally speaking for every single person that walks the planet. It's going to be very beneficial. Thank you for tuning in. See you next time.